Hello and welcome to the Supershape Coding Challenge Grand Finale. In the previous video, if you watched it, you didn't have to have watched it to follow this one, but if you watched it, I figured out how to make a sphere by iterating over latitude and longitudes and calculating spherical coordinates and creating a lot of triangle strips and coloring them like so. And you see that on your right, that pure, nice sphere with horizontal bands. And what I want to do in this video is show you how to take that sphere and turn it into this crazy looking super shape. Now this is just one example of a super shape. What are super shapes and where do they come from? So first of all, I want to reference you the work of Reza Ali. A link to his work will be in the description of this video. He has a wonderful art project all about super shapes that you can look at and enjoy, and some videos you can watch, beautiful ways of coloring and messing with them. This is really where I took my visual inspiration from, this particular work. Where I've got the math formula from is from Paul Bork's website. So what's going to happen, what we're going to do is, instead of simply saying something like, right, in this sphere that I've calculated, the point for the sort of x, y, z point for every single latitude and longitude, there is a radius, a sort of fixed radius of 200. So what if we had a kind of crazy way to calculate the radii? So for example, if we just use Perlin noise or a sine wave, we might see some rippling-like looking sphere. Well, it turns out this strange formula, for whatever reason, when you take either the latitude or longitude angle and calculate a radius based on this crazy formula, you get all sorts of values and you get these super shapes. And if I scroll down, we can see there's a whole bunch of kind of constants here. There's n2, there's a constant m, there's actually four. There's m, n1, n2, and n3. And if we scroll down here, you can see based on how you might set those values, those constants, you'll get different shapes. And this is actually the one that you're seeing in the particular example that I showed you. And you can see all sorts of various possibilities here. So the goal here is I'm going to make you, I'm making you, I don't know what that means. I am going to right now take that sphere and add those math formulas so that we can see these super shapes on the screen. I'm just going to scratch the surface on this. And it's my hope and my goal that you take this and do something creative and interesting with it, and I'll talk about what the possibilities might be at the end of this video. Okay, so let's just get started and think about some things we need to add and change to this. So I'm going to close, move around here for a second. I'm going to close this. And so this is the code that I right now have to work with. It uses just plain old spherical coordinates. So r is a fixed value of 200, and I get the x, y, z value, and then I draw and set the sphere. Now, what I'm going to do just briefly is kind of take color out of this for a second, because I think that'll help us kind of debug this a little bit. And I'm going to say stroke 255, no fill. And so there we can see, again, this is actually what's being drawn. This is just the kind of wire mesh of that sphere. And I'm also going to change this variable total up here to 25, just to make it a little less detailed, so we can might help us sort of see what's going on. Okay, so now that we're there, what do I need to change? And let me just give myself more space here, move some things around. What I need to do is simply change the math that's going on here. Instead of the pure spherical coordinates, where I just go from the latitude and longitude to a single radius, I want to have different radii values based on the latitude and longitude. So let's look at how that works. Once again, here is this formula. Now, I think what would be really useful would for me to have a kind of like visual reference of this formula always on the page while we're programming this. And I also am going to need this. So I'm taking some screenshots here. I should have done this in advance, but I'm just doing this in my video. I'm going to open these up with Mac Preview and put these up here in the corner. So as I'm writing the processing code, I can kind of have a reference to this. Okay. So, and actually, you know what might be useful? Let's make a function. Let's just say there's a function called supershape. And that function returns a radius value. And it returns a radius value, I'm going to say, based on what? Based on some amount of constants. So I need a I need m, I need n1, I need n2, and I need n3. So the idea here is that what I could do here is say R1 equals supershape based on some constants, like, oh, did I call it super? That would be a supershape. Supershape based on some constants, like the one that I'm going to do, I happen to have some constants memorized. I don't have them memorized. I'm going to go back to Paul Bork, and I want to look at let's start with this one. So I want these particular constants, 0.2, 1.7, 7.2, 1.7, and 1.7. So I'm going to do 0.2, 7, 0.2, 1.7, 1.7. And then actually what I need to do, one thing you'll notice about this supershape is that the spherical coordinates have been adjusted slightly, the way that this math works. And so I'm going to make those changes as well. So I'm going to change this to, cosine, cosine. I'm going to change this to sine, cosine. And I'm going to change this to sine. And then I also need to have these new values R1 and R2. So I'm going to say times R1 times R2 times R1 times R2. And I'll talk about what these are in a second. I'm just adding them into my code. And then also R2 times R2. So why are there two values? Well, pause. Back after an audio glitch. So what I was talking about was why is there an R1 and an R2? Well, what this 3D supershape actually is you can think about, if you remember, there is actually a previous video where I look at just a 2D supershape. And what the 3D supershape is, it's kind of like having a 2D supershape flat like this and a 2D supershape flat like this, and then rotated around each other. So in that sense, there's a radius that's determining, there's kind of a radius calculation for the one of those supershapes and a radius calculation for the other supershape. And those supershapes are calculated based on latitude and longitude. So what I need to do is calculate both an R1 that's based on, right now they're going to be the same, so I don't know if it actually matters. I need an R1 and I need an R2. So this is the idea, that I want an R1, which is supershape. And by the way, I forgot the most important parameter to this function, which is that I need to pass in that angle, latitude, and I need to pass in that angle, longitude. So I'm going to go back here, and I'm going to add the first argument as theta. So first thing I'm going to do is let's just see, whoops. And I lost my latitude, longitude. Oh, no, it's here. This has to go above. So there's a lot going on here on the screen here. But let me just take a moment to take a deep breath and look at it. So what I'm doing is I'm looking the same thing I did with the sphere. I'm saying for every latitude and for every longitude. Let's calculate a supershape radius value based on the latitude, a supershape radius value based on the longitude, and then apply those formulas. I actually have a mistake in those formulas that I can see now, which is that cosine longitude, and this is latitude, latitude. And then there's something else here, which is that for the calculations to work correctly, I want to have my latitude range, instead of going from 0 to pi, to go from negative pi over 2 to pi over 2, and longitude range as well. So I'm going to change those ranges to go from negative half pi to half pi, and then negative pi to pi. Now, one thing you'll notice is that this value r is not present here in this particular formula. What I'm going to do is calculate kind of a unit supershape that's based on the value of a range between 0 and 1, and I'm going to use that value r to expand its size. So I'm going to keep that as 200. And so let's just see if I run this. Right now the supershape function is just returning 1 no matter what, so I'm not actually doing the calculation. And if I run it, you should see I've basically still got that sphere. So I'm still getting the sphere. If the supershape calculation just returns 1 for R1 and R2 for every single value, I'm still going to have that sphere. So now it's up to us to put the math here correctly and not have things go too terribly awry. So let's give that a try. I've got R1 and R2 the wrong way around. So, so let me correct that, meaning that R1 should be based on a longitude like this, and R2 should be based on latitude like that. Let's see. So maybe that's the way. I guess I could look at the formula, maybe edit this out, and see that, right, R1, oh yeah, R1 of theta, so R1 of longitude. So R1 is based on longitude, yeah. So I should have just looked at this, by the way. You can see that this formula is saying calculate R1 value based on the longitude and R2 value based on R1 value, yes, based on the longitude and R2 value based on the latitude. Okay, so that should work. Okay, got it, I fixed it. Hopefully that's right. Let's still look at the result, and we should still have that sphere. I just had them backwards. Now, okay, let's come back here, and now we're going to start to put in that math. Oh boy, oh dear. So I'm going to give myself some nice room on the screen. I'm going to move this down and then move this over here so we can see that formula. So what are some things I need to calculate? Oh, and I forgot, there's A and B are constants too. I'm just going to, for now, you know, A and B are going to change sort of the quality of the shape in the sense that it's going to like stretch it or smush it on a horizontal or vertical axis. I'm going to leave those as 1 right now just for simplicity. And let's first calculate this particular value. So I'm going to say T1 equals 1 divided by A times cosine of m times theta divided by 4. And what do I want? I want the absolute value of that. And then I want to take T1 and set it equal to itself to the n2's power. So that's giving me just this component right here. I'm doing this particular math and setting that to the n2th power. Then let's do T2, which is the absolute value of 1 divided by b times sine times n times theta divided by 4. And I'm going to say T2 is itself to the n3 power. Then what I want to do is say T3, and I'm just using T as some arbitrary like variable naming structure. I want to just calculate the parts of these. I need to add T1 and T2 together, T1 plus T2. And then I need to take that and say T3, take to the power of -1 divided by n1. So then that's really what R is. So that's the end, right? Oh, no. Yes, the whole thing should be then float R equals the result of that, and I should be able to return R. So let's now, I don't know if I'm sure I made a mistake. Oh, somebody in the chat, A divided by B should be 1 divided by B. Oh yes, this should be 1 divided by B, thank you. I don't know if I have any other mistakes here in the math, but let's run this. Oh, I'm getting an error. I have some parentheses out of place. So absolute value of, there should be another parentheses here. And let's see what I get here. Miracle of miracles, that looks like that particular super shape. So we can see, let's have a look, right? It should look like this one. I am doing these values, I should get that. We can see that's what it looks like. A couple things just to be sure. I can give myself a little bit of a higher resolution by having 75 points for every latitude and longitude. I can also, what I can do is I can put the, well, let's run this again. Now you can see the resolution is finer. This looks pretty good. I am going to now give it just like a fill of white. Oh, and it says no fill right after that. So we can sort of see what that looks like. Okay, that looks still pretty good. I think we've got it. Okay, missing a bracket. I don't know. Somewhere I'm missing a bracket, but it looks right. Maybe that comment is in the past. Okay, so let's see if we can get one of the other super shapes to look right, and then we'll start messing with the color and maybe do some animation. Okay, So what I am going to do now is let's go back to Paul Bork and let's pick another one. I don't know, what looks like a nice looking one? Let's try this one. And so what you're going to notice is that there are now different values for Supershape 1 and 2. That means different values for R1 and R2, right? This two-dimensional supershape that's kind of all along the longitude, the two-dimensional supershape that's along the latitude, and they're rotated against each other. So what I'm going to do now is say, can we remember this? 8, 60, 130, 8, 60, 130. So I'm going to go here and say 8. Well, that's R2. I don't know if that it really matters. So let's do 8, 60, 100, 30. Now we're going to go back and say 2, 10, 10, 10, 2, 10, 10, 10. The Supershape song. 2, 10, 10, 10, 2, 10, 10, 10. So now I'm going to go up here and say 2, 10, 10, 10. Okay. Does this look, that looks kind of like what was in there, right? I can zoom out a little bit to see. I think that looks like that shape. So let's go back and see. Yeah, that looks right. So I think all of our formulas are looking correct. We can say I can put this at this angle. You can see those match up pretty well. We can actually go back and add that color stuff that I had before from the sphere, right? I can get rid of the stroke. And I can add hue. And I can have the hue kind of cycle, and we can see now I've made this rainbow super shape, and I can zoom out. So we're really moving along here. So you now can take this code and you can plug in the different values, see what shapes you can get. You can try different colors. You can try to make vertical stripes or horizontal stripes or have it animate. This would be nice to do actually really, really quickly. I could just add a variable like offset equals 0, and I'm going to, in the hue, I'm going to say hue plus offset mod 255, and I'll just say offset plus equals 5. I don't know what this is going to do, but you can see now I have my like cycling colors, and I want to like zoom in here, and then we can have this beautiful, why is it so, it looks kind of dark all of a sudden, but I have to stand in the middle of this. Whoa, okay. Oh wait, I'm actually recording a tutorial video, I forgot, not just like messing around. Okay, so you can see there's like lots of kind of crazy, oh, because the lights are over here. There we go, this is brighter now. Whoa, okay, I'm gonna make myself seasick. Okay, so you can see that there's all sorts of possibilities of things you can do. I wanna do one last thing in this video before I stop and give you some thoughts about other things you can do. Let's at least make it animate a little bit. So I wanna go back, I'm gonna comment, and I think, first of all, I think you could be a lot more thoughtful in terms of how you store these things as variables. I'm just kind of doing it haphazardly right now. But I'm going to go back to that, the first super shape, which has sort of equal values here. And it was 7.2, 1.7, 1.7. Did I get that right? Is that what it was? Let's see. Yeah, so you can see now here's this particular super shape that I started with. So what I want to do with this is now just show you how to animate it a little bit. So one thing I could actually do is just say, let me make this M a global variable. So I'm going to call this M, and I'm going to have a global variable called M and have that equal to 0. Now let me just run this right now and see what we get. With an M of 0, you can see this is actually just back to that sphere again, interestingly enough, because it kind of like cancels out, multiplying by 0 cancels out everything. So what I can now do is I could say something like M equals map mouse X, which goes from 0 to width between 0 and 7. So now as I start the sketch, you know, you can sort of see as I move the mouse around, it kind of morphs from that sphere all the way to that particular shape. And I could say, well, let me have some kind of global variable like angle. Well, I already have an angle variable. Like, let's just call this like M change. I don't know. I could probably think of something better. But I'm going to have a variable called M change and have that equal to 0. And what I'm going to do is I'm going to actually map sine of M change which is like a nice smooth oscillation, which goes between negative and 1 to between 0 and 7. And I'll have m change, change over time by some value. And then what I've got is this thing kind of like oscillating back and forth, almost like this weird super shaped breathing thing. I don't know why it's brighter on one side the way that I have the light set up. So it's, breathe. The camera's going to go off because I've hit 30 minutes. So, so you can see kind of what's going on here. There are a lot of possibilities. Now, the other thing that I would say is sort of interesting to think about is not just morphing from kind of 0, but what if you took two different super shapes and had those values interpolate between one to the other, so you actually morph one super shape into the other? That would be a great exercise for you to try. I think I've pretty much reached the end. The stream went offline. Okay, sorry, but hopefully this is recording anyway. So hopefully, I think I've reached the end of this particular tutorial. I hope that you try making some of the other super shapes, try playing with the variables and colors, see what kind of interface you could build for this. I am going to try to make a JavaScript WebGL version of this, in which case it might be easier to have an interface that controls these shapes. And so stay tuned. I'll either just post that code in the description of this video, or you'll see another video kind of converting this code to JavaScript. Thanks for watching the SuperShape tutorial, and I'm sure you're going to have questions and comments and thoughts, so please let me know in the variety of channels that exist to you to communicate with me, perhaps. Okay, for real. I mean, not perhaps. Whatever. Okay, no, bye.